We are starting the demo video for measurement of low resistance and calibration of voltmeter using Crompton potentiometer trainer kit. In this trainer kit, we have a standardizing method of the galvanometer, which is done using coarse and fine rheostat. In the coarse rheostat, you have your fixed resistance, and in the fine rheostat, you have variable resistance through potentiometer. You have the ports for your test, unknown test of the meter. You have your 2-volt cell and the standard cell, and here we have the millivolt Crompton potentiometer device. This area will be used to measure the unknown resistance, and we have a standard resistance of 1 ohm internal. So as per our manual which we have provided to you, there are 2 experiments which need to be done. The first one would be, the first part of any experiment would be to standardize the potentiometer. Now to standardize the potentiometer, what we first do is we set the dial of the voltage, exact voltage, to 1 volt. Then we turn on the trainer kit. Then we first check if the cell is standardized. If we are pressing the button and the needle is not at null, we need to first use these two to set it to 0 nil position. So right now you can see that there is no deflection in the galvanometer, and even after pressing it there is no movement. You can see that there will be some movement once I start moving the pot. Now we do not have to change these 2 pots for the next 2 experiments. So now, and as in the manual, you can see the first is the calibration of the voltmeter. For calibration of voltmeter, what we'll first do is we'll connect the red terminal, that is the positive terminal, to the V2 plus the point, the negative terminal of the voltmeter to V1 negative point. We will first set the supply to 1 volt. Now we will carefully remove the negative terminal and connect it to test unknown negative terminal, the V2, this positive, to this one. Now what we need to do is we need to set the volt to 0.75 and then press test. You can see that the potentiometer is moving, galvanometer is in the positive direction. So I am moving the millivolt meter to calibrate my output. I will move this till the time I get 0 deflection. Right now, avoiding the parallax, the output is 220. So this is 220 millivolt and this is 0.75. So this comes to round about near 1, not exactly 1. So that will be around 0.98. So that is the exact error that we are getting in the analog meter, that is 0.02 volt. So that is the part of calibration of voltmeter. So now coming to the next experiment, in that we have our unknown resistance. Here you can also use another resistance from the laboratory or any other application. The standard resistance here is 1. Now what we need to do is we need to connect the red terminal to plus and black terminal to minus. Now we need to calculate as per the experiment to find out the unknown resistance. The formula is resistance unknown R2 is equal to V2 by V1 into R1. Our R1 is 1 ohm. V2 by V1 is basically the potential difference of this and this. To calculate V2, we need to connect positive to this terminal and negative to green terminal. So it is 0.5. Now V1, this is also 0.5. So as per our formula, the unknown resistance will be 0.5 divided by 0.5, that is 1 into 1. So unknown resistance is 1 ohm. Now to check that if the calculated resistance and actual resistance is same, we are using a proper calibrated multimeter. We have set it to resistance. The resistance is coming at 0.8, that is around 1. The resistance what we are getting here is 0.9. The meter is little bit out. So this is basically as per resistance parameter. This is 1 ohm. So we have calculated the unknown resistance. Thank you.